Let's take a look at the Pythagorean Theorem. What is that special relationship of right triangles?
Now, you have to remember that Pythagoras was born in Greece around 550 BC, and he was experimenting with all kinds of things with triangles, but he's more famously known for finding out this thing called the Pythagorean Theorem. And what he did was he looked at right triangles in specific, and he called the two sides of the primary angle legs, and he called the angle opposite of the angle the hypotenuse. Now, in so doing, that allowed him to be able to create a theorem. He labeled the legs A and B as well, and the hypotenuse C. Now, what he did is said, hey, if he took the value of A and squared it, added it to the value of B and squared it, that would equal to the value of C and squared it, based on this triangle idea, A, B, and C. So, let's take a look at this triangle here and get a little deeper meaning of what A squared plus B squared equals C squared. What he's saying is that if he had a square, this square here is a 4 by 4 square, and by definition, a square has equal sides. So this side of the triangle measures 4, so I could put a 4 by 4 square there. This side of the triangle measures 3, and here I could put a 3 by 3 square. And if I took all of these pieces, they would both, and add them together, because that's what Pythagorean theorem says, that if I take this A, and it's a square, and this square, which happens to be, we'll call it B, if I put these together, I'm going to get this entire square. So I can prove it using a really cool app or program on the internet. It's put out by pbs.org, which is a proof on the Pythagorean theorem. And I'm going to put it up here and kind of walk you through it a little bit. So here I have that square, that A by A square, and I'm going to drag this A by A square and drop it in there. Now you can see as I drag this B by B square, it's not going to fit in there, is it? So it doesn't fit. So what I'm going to have to do is break it up into pieces. We know that the B by B is made of 9 individual pieces. But if I take these individual pieces, I could drop them in and put it all together to show that it will all fit inside that strip all the way around and build that square. So, using that concept, let's move forward and take a look at some triangles. Now, here I have a right triangle, and here's the right angle, and I have two sides here, 24 and 10, and these are legs because opposite of the right angle is the hypotenuse, so that would be C. We'll label this A and B for right now. So I have A squared plus B squared equals C squared. So what I'm going to do is I am going to substitute the values that I have, this value of A, which is 24, I'm going to put it in here as 24 squared. The 10 I'm going to drop into the B slot equals C squared. And what I'm going to do is simplify this. I know that 24 times 24 is 576. 10 times 10 is 100. And that's going to give us the side of that square that's sitting out there. I add them together, I get 676 equals C squared. So we know if I broke up that square on the hypotenuse, that would be 676 pieces. But I don't want to know how many pieces are in the square. I want to know the measurement of this side of C, just that one side of that giant square that's out there. I want to know what's just a side measurement right here. So the way I do that is I take the square root of each side, because we know the square root, by definition, is the measurement of a side of a square. So when I take the square root of 676, I get 26. And the square root of C squared is C, just as if the square root of the side of C, it would be C by C, so this side would measure C. So that's how we would find it. Let's try it again on another one here. Here I have an 8 by 15. And again, opposite of the right angle would be the C, or the hypotenuse. So again, we're looking for C. So A squared plus B squared equals C squared, the theorem. I'm going to call 8A and 15B. It doesn't matter which is considered A or B, because the legs are interchangeable with regards to the theorem, because we're basically adding them together. 8 times 8 is 64. 15 times 15 is 225. We're going to add these two together. We get 289. And again, what we do in order to find the side measurement of C, we would take the square root of both sides, and we would get that C was equal to a measurement of 17. Now, it's pretty straightforward and easy to use when we're looking for the hypotenuse. What happens when we are given the hypotenuse? There it is, the value of 34. But we're missing one of the leg measurements. So we're going to call this side A and this side B, just like we normally do, one on each side of the right angle. And we're still going to stand with our formula a squared plus b squared equals c squared, because Pythagoras said this is the formula we use to find sides of right triangles. Well, since we don't know what a is, we are going to leave a squared alone. In place of the b, I'm going to put 30, and in place of the c, I'm going to put 34. Now we'll go through and simplify. I know 30 times 30 is 900, and 34 times 34 is equal to 1156. Now, in order to, what this is telling me is that something plus 900 is going to give me 1156. So in order to figure that out, I've got to subtract these numbers. So I'm going to subtract 900 from both sides, because we know 900 minus 900 is 0, so it goes away. A squared plus 0 is just a squared. 1156 minus 900 is 256. So once again, I have a square that measures 256 units. I want the side measurement of the square, so I'm going to take the square root of both sides, and I find out that a equals 16. We're going to do this one more time. Here it is in example 4. Again, opposite the right angle is the hypotenuse, which is C. The sides we can label A and B, and we would set them up again. A squared plus B squared equals C squared. We would drop in the numbers that we know. A would be 12, so that would be 12 squared, plus B squared we don't know, and C, which is 15, and we would square that. We would simplify it. 12 times 12 is 144, plus B squared equals 15 times 15, which is 225. Again, in order to get this B squared alone, we're saying 144 plus something gives us 225. We know that we need to find out what that something is, so we're going to subtract 144 from both sides. Once we do that, we find out that B squared is equal to 81. Again, we found out that there was a square on this side of the triangle that had an area, B by B has an area of 81. So an 81 squares of some sort. So what that means is we've got to find that side measurement. And the way we do that is we take the square root of both sides. That tells us that the square root of B squared is B, and the square root of 81 is 9. Hopefully you've got a basic understanding of how the theorem works and how we use it for right triangles.